Okay, let's go on. Looking at notes 3.8 today. Notes 3.8 for you to look at. So we're going to go over that. If you are in first period, I can't come to class today, so sorry about that. And if you're in second or third, I'm probably going to also just go ahead and point you towards this recorded version of the notes. That way I don't have to do it in class. So here we go. Factoring. We started factoring last class, review to Algebra 1, but we started factoring the GCF on Friday or Monday's class, whenever you had it. Today we're going to factor quadratic trinomials back into two binomials. So we're going to factor some quadratic three-term expressions into two-term expressions. Binomial is a two-term expression. Trinomial, three-term. Binomial, two-term. Okay. So some tips here. The first and last terms are usually the easy parts. It's the outer and inner terms that we have to work to figure out. And there's a couple ways to do it, and an X method, an X method that some people like. I'm going to show you how I do it. Okay, so again, before we quite get into it, factoring is like multiplying. It's the opposite of multiplying, right? So what if I have x plus 2, we'll do an easy one, x plus 2 times x plus 3, right? That's 2, but to multiply this is really easy. Do x times x, x squared. X times 3, 3x. 2 times x, 2x. 2 times 3, 6. And then you combine these middle terms to get x squared plus 5x plus 6, right? So if I'm doing the opposite of that, I'm working backwards from that, how did the 6 get here? Well, the 6 is just 2 times 3. The x squared is x times x. So these outside ones are the easier ones to look at. They're the ones that you should start off focusing on. You should start off focusing on that. And then you kind of work your way to get 5. So say 6, oh, that's what, 2 and 3? 2 plus 3 is 5? Yeah. So that's how I do it. So hopefully this will make sense as you practice. So again, let's zoom in here. I'm going to look at, I know my final answer is going to look like this. Our final answers are always going to be two binomials. So something plus something. I know that, right? And I know that this term, the x squared, I get that from multiplying the first two things, right? Again, like an example I did, this x squared we got from multiplying those two x's together. And so I can start off, if it's just x squared, I know, okay, well, that's going to be x times x. That's the only way to get x squared is x times x, right? And then I think, okay, let me focus on the outside. 2. How can I get 2? What times what is 2? 2 times 1. That's the only way to get 2. 2 times 1 is 2. Negative 1 times negative 2 is also a way to do it if there's negatives. But here, let's focus on positives. 2 times 1 is 2, right? 2 times 1 is 2. And if I put that here, 1 times x is 1x, the inside. 2 times x is 2x, so that's 1x, it's 2x. That's how I get 3x, right? So that one works out. So again, here's how you do it. Let's look at the next example. Okay, I know I'm going to end up in an answer like this. X times x is x squared. That's the only way to get x squared. I need two numbers that multiply to negative 20 and that add up, that when I add them up, I'm going to get this middle term. So what are some numbers that multiply to 20? You got what? 1 and 20, 2 and 10, 4 and 5. And I know that they have to be negative because to get the third term here is when you multiply two numbers together. You multiply two numbers together, and one of them is negative because the only way to multiply two numbers together and end up with a negative product is if one of those numbers was negative. And they add up to positive 1. So two numbers that they multiply to negative 20, they add up to positive 1. So if you kind of look at these numbers, you would think, oh, negative 4 and 5. Negative 4 times 5 is negative 20. And negative 4 plus 5 is positive 1. So there's your answer. X minus 4 times x plus 5. So again, look at this number here. I know my answer is going to look like this. The answer always has to look like that. The first value I look at is x squared. How do I get x squared? There's only one way to get x squared. X and x. It's the only way to get x squared. I look at the third value, positive 6. How do I multiply two values to get positive 6? I got 1 and 6, 2 and 3, right? That's for 6. 1 and 6, 2 and 3. It's the only way. It's the only way to get 6. And I know I'm going to add them together. I'm going to add them together, and I need to get negative 5. I multiply, and you get 6. I add and get negative 5. Well, if I multiply and get a positive number, that means they're the same sign. They're either both positive, or they might both be negative. And if I add them together, and I get a negative, that tells me they have to be negative. So what two numbers add up to negative 5? Negative 2 and negative 3. Right? X, and you can always FOIL it back out to check. X times x is x squared. X times negative 3 is negative 3x. Negative 2 times x is negative 2x. Negative 2 times negative 3 is positive 6. Add them together, right? This is what you start off with. So you know that this has to be right. You can check every answer. You can check them. D is a little different. So D is combining some certain things. D, you might look at D and think, oh, wait a minute. D hopefully jumps off at you because there's a GCF here. Sometimes there is a GCF. Sometimes there's a GCF. So before we start factoring into two binomials, we'll factor out the GCF. And so it might not jump off the page at you, but here it's 4. 4 times 1 is 4. 4 times 6 is 24. 4 times 8 is 32. So 4 is the GCF here. So let me factor the 4 out first. Okay. Now the reason why we factor out the 4 is now what I have left in the parentheses is way easier to deal with. This is way easier to factor out. Because again, I'm going to have the 4 stays there, but I want to end up with something like this. The two binomials. How do I get x squared? Well, again, that's just x and x. Right? X and x. I need two numbers that multiply to 8 and add up to 6. Two numbers that multiply to 8 and add up to 6. All right? 2 and 4. 2 times 4 is 8. 2 plus 4 is 6. So here's your complete factoring out. So you factor out the GCF first, and then you factor out anything else if it's there. Now, it doesn't always have a GCF. So E, I look at E here and say, oh, it's not 1x squared, it's 6x squared. Can I factor out something here? This one you can't. So you got to do a little more work. That's okay. You're going to practice out. So, okay, so now we still have two binomials like this. I think, how do I get 6x squared? Well, there's two ways to get 6x squared. 6x times x or 2x times 3x. So I don't know how to do it. Let's go with our gut. Let's go with our gut. I'm going to go with my gut here and say 2x and 3x. So that's, you're going to check in a sec, but we're going to start there. And then I'm going to start with 1. How do I get 1, right? Because we always focus on this term first, and then we focus on that term. So how do you get 1? What times what is 1? It's only 1, right? 1 times 1 is 1. That's the only way to get 1. There's no other way to get 1. It's 1 times 1, right? Plus 1, plus 1. And then you have to check. You can't assume you're right. You got to check here. So let's FOIL this out together. So 2x times 3x is 6x squared. 2 times 1 is 2. 1 times 3 is 3. 1 times 1 is 1. You end up with 6x squared plus 5x plus 1. Is that what we started off with? No, it's not. So we're wrong. That's okay though, because now I know that this is not right. And I wasn't sure to begin with, so I checked off. I know that's not right. So now I know what is right. It has to be another possibility. It'd be, I'll do this on paper right here. Right? Before we thought maybe it's 2 and 3x, 2x, 3x. Now, but I was wrong. So it must be 6x and x, right? That's another way to get 6x squared. So, still, it's plus 1, the same thing. And then if you were to FOIL that out, you get that's the answer. Right? So 6x plus 1 times x plus 1. You're not always right the first time. So there's that. Okay, next problem. 3x squared minus 8x plus 4. This is nice. This is nice because 3 is a prime number. 3 is a prime number. So there's only one way to get 3x squared. Only one possible way to get 3x squared. It's 3x and x. It's the only way to get 3x squared. Now, 4, a little trickier. 4 could be tricky because 4 could be 4 times 1, or it could be 2 times 2. I'm going to go with my gut here and try 2 times 2. And then I know that because this is positive, this plus 4, positive 4, that these two numbers have to be the same sign. They're either both positive or they're both negative. And this negative 8 here, it's negative. I said negative, so you know it's negative. So that tells me that these have to be both negative. So plus here means same sign. Negative tells you the sign. They're both negative. So minus 2, minus 2. And then, of course, if you FOIL that out, let's do it again. 3x times x, 3x squared. 3 times negative 2 is negative 6x. Negative 2 times x, negative 2x. Negative 2 times negative 2 is positive 4. And you have what you started with. So you know these, I shouldn't have boxed that. This is what I'm boxing. So there's your answer right there. So you check your work. You check your work. Let's do a couple more. I'm going to be doing this for 12 minutes. Okay, I can do it a little longer. I want the notes to be about 25 minutes. Look at G. G is a special case. G is special. What? Hopefully you see what is different about G. There's something different about G. It's also about L here. You can see L too. There's something different. There's something different. And I hope it's obvious to you, but it's missing the B value. It's missing the x to the first power, right? Like here on F, the B value is negative 8. The B value here is 5 or 11. But on G, there is no B value. There's no B value. That's a special type of factoring problem. It is a difference of two squares. This is a difference of two squares. Whenever I see that, I immediately think difference of two squares. And then I go further and I say, oh, x squared. That's a squared value. That's x times x. 25, that's 5 times 5. That's the difference, right? Minus, that means difference of two squares. X squared and 5 squared. This is really x squared minus 5 squared. Difference of two squares. This can automatically be factored into x minus 5 times x plus 5. It can always automatically be factored into that without doing any real math. Like L, for example. I see it, I automatically know it's a difference of two squares. So I know this is really x squared minus some value squared, 121. If you don't know your squares, that's 11 squared. 10 squared is 100. 11 squared is 121. So this is x squared minus 11 squared, so it factors to x minus 11 times x plus 11. Difference two squares. That's a special case. Special case. I'll do a couple more. One other special case to see. So now look at h. Is h different than the ones we've done so far? Obviously, yes, it is different because x to the fourth power plus 9x squared plus 20. So here's how you do h. You rewrite it. You think, okay, well, I like it to be in a form. I like it to be in this form, right? I always want it to be in this form. Ax squared plus bx plus c. This is a form I like. This is a good form. I like this form. Where it's something squared and then something to the first power. You don't write the one, but you can think of that. Right? I like that. And really, it's x to the 0th power if you want to think about that. We don't write the x to the 0, but that's really what you can think of that as. So I say, oh man, that's the form I like. This is not in the form I like. Is there a way I could get into the form that I like? Yeah, they can. This is actually x squared plus 9x squared plus 20. So it's really, I mean, what if I rewrite this like this? I'm gonna say, okay, I'm gonna say that q equals x squared, and I'm gonna write this again as q squared plus 9q plus 20. Right? Is this really that different than this? It's not different at all. It's just, okay, there's a q instead of an x. It's the same thing. So I'll factor it just like the way I factored everything else. How do I get q squared? That's q times q. How do you get 20? 20. 1 times 20, 2 times 10, 4 times 5. That's the only way to get 20. 1 times 20, 2 and 10, 4 and 5. That's it. That's the only way to get 20. And I want to add up to 9. What adds up to 9? 1, 20. That's 21. Nope. 2, 10. That's 12. Nope. 4 and 5. 4 and 5. That's 9. So I end up with q plus 4 times q plus 5. And then after you've solved it, now I can replace it. I can get rid of q. I say, what does q equal? Well, q equals x squared, right? So I'm going to just rewrite that again with x squared plus 4 times x squared plus 5. That's how you would solve that. So you simplify it. You kind of trick yourself into making it look like a regular problem. Then you factor it, and then you rewrite it what it is. That's how you solve those. Don't let those freak you out. All right, so geez, there's so many problems to do here. That's about them. That's about it. I'm gonna look at a couple of these weird ones here on the back. In the back here, I'm not gonna do. There's no way I'm gonna do all these. I'll look at the harder ones. So again, I look for. I want to factor. I want to square stuff. I want to do something. I want to do something here. What are the hard ones? Okay, let's do a random assortment ones. The easy one. Okay, x squared plus 15x plus 26. If there's just x squared by itself, it tends to be the easier one. So again, that's gonna be x and x. 56. How do I get 56? 56. 56. That's gonna be 9 times 7. No, not 9 times 7. Sorry. 8 times 7. 8 times 7 is 56. Another way. Here's how I usually do 56 or do like numbers like that. I say 156. 2, so divided by 2, that would be 28, 2 and 28. I can do that. 4 and 14. I can do 8 and 7, and that's it. Those are the numbers I got. Does 3 go in there? 3 does not. 3 does not. So those numbers. Which those add up to 15, 8 and 7 do. So 8 plus x plus 8. X plus 7. Check. Number 5, 2x squared plus 11x. What's that going to be? So again, 2x squared, that's going to be 2x and x. It's the only way to get 2x squared. Negative 6, you're going to have a positive negative number. So it could be negative 3, could be 2, it could be negative 6 and 2. I have to add it to 11. 11 is a somewhat big number. How do I get 11? 11 is really close to 12, right? 12. 12 is 6 and 2. So what if I do plus 6 here minus 1? That would be my answer. And again, it's like a check thing. You do it enough. I've been doing this for like 10 years, right? I taught it for 8, and then went to high school. So I have a lot of practice. So you practice more, you start to see it. I'm going to skip this one. Same thing. Just do the same thing, but instead of x to the fourth, make it x squared. Make that x, and then just solve it. But then you rewrite it as x squared, right? So again, should be x and x, right? If you pretend it's the same thing. 12. How do I get 12 and get it to negative 7? So 12, I need two numbers, same sign. It's a positive 12, so same sign. They add up to a negative. That means they're both negative. Both negative. Both negative. 12 and 7. 12, that's 1 and 12. 2 and 6. 3 and 4. Which of those get you to 7? 3 and 4. 3 and 4 get you to 7. And remember, it should be squared because it was x to the fourth starting off. So that's how you do that one. It's a practice thing. You just practice. Keep practicing. This one, I don't think it's factorable. This one's not factorable. Because it's not a difference to squares. Is it factorable? No, I don't think it is. No, that's not factorable. 8 and 9, very similar. Difference two squares. You don't see. You see like two terms, and you say are they perfect squares? 4x squared is 2x squared. 2x times 2x is 4x squared. Minus 9y cubed, that's 3y squared. When you see 4, 9, 16, 25, 36, 49, 49, 64, 81, those are perfect squares. So that should be like a hint that that's what that problem is. So this becomes 2x minus 3y times 2x plus 3y. It's a difference of two squares. Let's see, I'm going to do a couple more. Number 12, this one here, how can I factor that out? Well, first off, as always, is there a GCF? Is there a GCF? There's a GCF, factor that out. And then factor out the negative 2 here. I factor out the negative 2, I get x squared minus 100. That's the difference of two squares. So this factors out. Remember, that's x squared minus 10 squared. Difference of two squares. So it's always going to be the first thing minus the second times the first thing plus the second. And negative 2 is still there. Difference of two squares. 13, same thing. Difference of two squares. A to the fourth. You say, well, that's not a square. Yeah, it is. It's a squared squared. Minus 81. It's 81. That's 9 squared. First thing minus the second. So a squared minus 9 times the first thing, a squared, plus the second. There you go. Difference two squares. Last one I'll look at. We're at almost the 25-minute mark, so I'm bouncing around. Number 14. Do the couple word problems. The word problems are always the hardest. The area of a rectangle is given by 3x squared plus 17x plus 10. So here we have some equation here, right? If the length of the rectangle is that, what is the width? Well, just length times width is what? Area, right? That's how area works. Length times width is area. So the length 3x plus 2 times something equals 3x squared plus 17x plus 10. They're asking you to factor this. They're saying, hey, factor this. And they say one of the factors is this. What's the other factor? So let's just factor it. We're just going to factor this, okay? So here we go, just factoring it. 3x squared plus 7x plus 10. So how do I get 3x squared? How do I get that? Well, that's just 3x and x. There's only one way to get 3x squared. It's 3x and x. That's the only way to get 3x squared. How do I get 10? How do I get 10? Well, 10 is, what, 1 times 10? 2 times 5? That's it, 2 times 5. 1 and 10, 2 and 5, that's it. And I want to add up to 17. I have a 3 here. I want to add it to 17. What? 17. I have 2 and 5, 17. 2 and 5, 17. Well, 3 times 5 is 15, and 15 plus 2 is 17. So the 3 needs to go with the 5. The 2 goes with the x here, right? 3 times 5, 15x. 2 times x, 2x. 2 and 15 is 17. So these are your factors. 3x squared times x plus 5. You already knew the 3x plus 2. So then x plus 5. This is your width. Last one, same thing. Here's some quadratic. Factor it. 6x squared, that could be 6 and 1 or 2 and 3. My gut always says do 2 and 3, so I'll try that. Negative 3, positive 1, negative 3, or negative 1, positive 3. There's only one way to get 3 is 1 times 3. 1 is negative, 1 is positive. And I know one of them is 2x plus 3. So then the other one has to be minus 1, because 3 times negative 1 is negative 3. So what is the width here? That's the width. All right, that is a little bit under 30 minutes, so that's pretty good for the notes. So after this, just look at the homework, practice on it, and then on Friday's class, when I see you, you can ask me questions. I'm also going to put an additional delta math up there. I'm going to put an additional delta math because that is how you can practice factoring, more so than doing a homework. I'm gonna add a delta math there. I'm gonna add, and I'll explain how that works. But the delta math will help be a bonus assignment, bonus for anyone who wants to pick their grade up. A bonus assignment, delta math. I will put an announcement on that, so look for that. All right. So again, sorry I can't be in class on Wednesday, but here's the notes, and I'll see you guys on Friday. All right, bye.